Welcome to the world of category theory, often described as the mathematics of mathematics. At its core, category theory is the study of mathematical structures and the relationships between them, symbolized by the circle symbol. It provides a high-level framework for understanding and unifying different areas of mathematics. Category theory serves as a unifying language for mathematics, focusing on the relationships between different structures. Instead of delving into the internal details of mathematical objects, it emphasizes how these objects relate to one another. It is the study of relationships. In category theory, objects are abstract entities within a category. Examples of objects include sets, numbers, functions, and spaces. Objects are fundamental building blocks that category theory uses to build mathematical structures. Morphisms, also known as arrows, represent relationships between objects. A morphism is notated as F from object A to object B, where F signifies the relationship or transformation from object A to object B. A category consists of a collection of objects and morphisms. To be a valid category, it must satisfy two requirements: identity and composition. Every object A must have an identity morphism, ID subscript, that maps A to itself. Also, morphisms must be composable. Composition is a rule that combines morphisms. If there is a morphism F from object A to object B, and another morphism G from object B to object C, then they can be composed to form a morphism G circle F from object A to object C. Functors are mappings between categories. A functor, denoted as F, maps category C to category D. It preserves objects where F of A and F of B are the mapped objects. It also preserves morphisms, such as F of F from A to B. Importantly, functors also preserves the structure of categories, including composition and identity. Natural transformations are transformations between functors, denoted as alpha from F to G. A key property of natural transformations is naturality, which ensures commuting squares. Natural transformations maps objects to morphisms. Universal properties characterizes objects by their relationships, particularly through a unique factorization property. It defines objects up to isomorphism and provides the best solution to a problem. Category theory finds applications in various fields. In mathematics, it is used in algebraic topology, homological algebra, and differential geometry. In computer science, it is applied in programming languages, type theory, and database theory. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.